Hello, I'm here to share my DQ1. The question was, consider an array of 100 integers which are completely unsorted. Provide a code snippet that will find the largest number in the array and calculate the number of computational steps required. So I wasn't sure if the question was asking us to code the number of computational steps required. I didn't code that because I wasn't really sure how to go about it. But if that is the requirement, please let me know and I'll redo it. But this is my code snippet for the array of 100 random numbers and finding the largest number. So I started with creating the container for the numbers, which was just, an array of 100, as the question stated. And then I wanted to populate that array with 100 numbers between 1 and 1,000. So you can see the random here telling you 1,000 numbers, and it's returning my array. So every time that I run this, it goes through this for loop and creates an array of numbers 1 to 1,000, 100 of them. So then I needed to find the maximum. So down here you can see where it has the maximum numbers. So to get the maximum, we're initializing the array for the maximum, calling random again. And then we need to, why am I doing this again? Sorry. So then we're comparing all the numbers together until we find the biggest one. Basically, we're iterating through it, going one by one for, if a number equals 1, if the number is bigger than the number in length, blah, blah, blah. So once we iterate through all of these numbers, we're returning the maximum number. And then down here in my main, I'm just printing out which one's the maximum. So you can see it right here, whatever the largest number may be. You can go through it over and over again. It's endless. So as far as I understand, the big O method, which I'm completely new to, so each iteration through is O to the N. So I guess that's how you say O to the N, O times N. So for the create array method, the loop iterates N number of times, which is in our case 100 because it's the length of the array. So it's going to iterate an N number of times. So the time complexity is ON. And then you go to the next loop down here in our algorithms and whatever. And this also iterates an N number of times, depending on how many times it has to compare the numbers. Yeah. And that's kind of undetermined until, well, I guess you could statistically calculate that. But again, it's O times N. And then since both methods are linear, they don't, they're not nested, so they're running completely separate from each other. You run one and then the other. It's O times N plus O times N, which just simplifies to O times N. So the time complexity really didn't change because I didn't nest anything. So I think that's it. Let me know if I'm wrong.